Hi class, I've stopped doing the live feeds because they take about 24 hours or at least 12 hours to upload. So that's not really helping you. I'm just going to pre-record the video and upload it. That way you'll have it. You'll have access to it a couple hours later or an hour later, but at least you'll have access to it immediately, comparatively speaking, if you're not watching me on the live feed. So I'm going to do numbers 114 and 115 on the board. The question is this. The arsenic in a 1.22 gram sample of a pesticide was converted to arsenate, AsO4 with a -3 charge, by suitable chemical treatment. It was then titrated using silver ions to form silver arsenate as a precipitate. A, what is the oxidation state of arsenic in arsenate? B, name silver arsenate by analogy to the corresponding compound containing phosphorus in place of arsenic. And C, if it took 25 milliliters of 0.102 molar silver ions to reach the equivalence point in its titration, what is the mass percentage of arsenic in the pesticide? Okay, whip up the calculator. First part of it, what is the oxidation state of arsenic in arsenate? Well, I used the marker. This one's done too. So we're asked to find the oxidation state of arsenic in this polyatomic ion. Oxygen typically has a -2 charge, and there's 4 of them there, so you would expect a -8 charge, but the overall charge on the ion is -3. So that points to arsenic having an oxidation state of +5. In part B, they ask, name Ag3ASO4 by analogy to the corresponding compound containing phosphorus in place of arsenic. That's called silver arsenate. Ag3ASO4 is silver arsenate. Part C. If it took 25 milliliters of 0.102 molar silver. Okay, let's write that over here. Top again. So it's titrated with silver. To give you the silver arsenate. And it took 25 milliliters of 0.102 molar to titrate it. What is the mass percent? And the original sample of arsenic, so remember arsenic was turned into arsenate, and there was a mix there, and it was 1.22 grams of pesticide. Right, there's other stuff in there mixed in there. So the 1.22 grams wasn't all arsenic. It's being oxidized to the arsenate. First of all, let's find out how many moles of arsenic were present. We know that the number of moles of silver is given by the molarity times the volume. The molarity here is 0.102 moles per liter. And therefore the volume, and then the volume is 25.0 thousandths of a liter. And that's going to give you 0.102. I just need a little more light here. That's too bright. It creates glare. About that. That's better. So 0.102 times 0.025 gives you 2.55 times 10 to the minus 3 moles of silver. Now, that has a stoichiometry of 3 to 1. So they're asking times 1 mole of arsenate is titrated for every 3 moles of silver that was used. As you can see here, well, I didn't put the 3 there. So the amount of, now you know what I did? That's correct. So divide that by 3. Moles of silver, of course, will cancel, and we have 8.50 times 10 to the minus 4 moles of arsenate have been titrated with this stoichiometry, which means you also had the same number of moles of arsenic. Therefore, if you multiply by the molar mass of arsenic, which is 74.9216, you'll get how many grams of arsenic were in the original sample. So times 74.9216 tells you that you had 6.368336 times 10 to the negative 2 grams of arsenic in the original sample. The sample of pesticide weighs 1.22 grams. So if you have, what they're asking in the last part of the question is, what is the mass percentage of arsenic in the pesticide? So 6.36, etc., times 10 to the negative 2 over 1.22 times 100 is going to give you the mass percent content of arsenic in the pesticide. So divide that by 1.22 times 100, and what you get is 5.21994.754% percent arsenic. I think you're only allowed 3 sig figs, so you say 5.22 grams at 5.22% arsenic. Question 115. These are pretty challenging questions. I don't know that I would expect you to get those, but I would like you to be able to get them. Because if you can get questions like that, then you've understood the concepts in the chapter clearly. 115, the new standard for arsenate in drinking water, mandated by the Safe Drinking Water Act, requires that by January 2006, public water supplies must contain no greater than 10 parts per billion arsenic. Assuming that this arsenic is present as arsenate, what mass of sodium arsenate would be present in a 1 liter sample of drinking water that just meets the standard? So if you have 10 parts per billion of arsenic, 10 ppb. So suppose you're drinking water. Excuse me, I'm just gonna blow my nose. So you have 10 parts per billion of sodium arsenate, is it? So 10 parts per billion of sodium arsenate, which would be this, in 1.0 liter of water. How many grams? So let's assume the density of water is, we're going to do this weight by weight. So let's turn a kilogram of water, well, a liter of water, times its density, which is around 1. So you're going to have, first of all, it's 1,000 milliliters times 1.0 grams per milliliter means you have 1,000 grams of water. Now let's turn that 1,000 grams into a billion somethings. 1,000 grams. I actually had a better way of doing it. 1,000 grams equals 1 kilogram. How many nanograms? Because that's billions, right? So that's 1 kilogram is equal to 10 to the 9 nanograms per No, I had it in grams. I'm sorry. I'm waffling a little bit here. Times 10 to the 9 nanograms per 1 gram. That would work. Okay, so that means you have 10 to the 12 nanograms of water, because the grams will cancel. If you have 10 to the 12 nanograms and your concentration is 10 nanograms for every 10 to the 9 nanograms, because that's what 10 parts per billion means, right? A billion is 10 to the 9. So if you have 10 nanograms for every billion grams, which is contaminated with the substance sodium arsenate, then all you have to do is cancel the nanograms. I should say also 10 nanograms of sodium arsenate for every billion nanograms of solution. And here you have that many nanograms of solution. So there's the proper units. Solution cancels, nanograms cancels. So you'll have 10 to the 12 divided 10 to the 9, which is 10 to the 3. Gosh. 10 to the 3 times 10 is 10 to the 4 nanograms of sodium arsenate. Is that answering the actual question? It says, well, that's the mass of sodium arsenate that would be present. 10 to the 4 nanograms, or if you like, 10 to the 4 times 10 to the 9 of a gram equals, because a nanogram is 10 to the 9 of a gram, and 10 to the 4 9. rid of nanograms, you get 10 to the negative 5 grams of sodium arsenic. Okay, so it's 10 to the minus 5 of a gram. Probably it's better to report it as nanograms. So 10,000 nanograms, or if you like, 10 micrograms. There's 10 micrograms, because micrograms is 1,000 times bigger unit than nanograms. Okay. I think we should do another titration. This number 102 is interesting. I'll do that one for you if you can follow along. And I think you should watch some titration, some videos from the titration playlist, because I do probably all these other problems over again. And it's good practice for you. Anyway, let's try 102 together. It says tartaric acid has two acidic hydrogens. The acid is often present in wines and precipitates from solution as the wine ages. A solution containing an unknown concentration of the acid is titrated with sodium hydroxide. It requires 22.62 milliliters of 0.2 molar sodium hydroxide solution to titrate both acidic protons in 40 milliliters of tartaric acid solution. Write a balanced net ionic equation for the neutralization reaction and to calculate the molarity of the tartaric acid solution. So let's copy the equation, the molecular equation, to solve the problem first of all. You know what, I'm going to change my marker because this one is no longer writing properly. Let's try blue today. So we have H2, C4, H4O6, and it's being titrated with NaOH, which is aqueous, of course. This is also aqueous. And then it gives you sodium. It gives you two equivalents. You need two equivalents because it's got two protons. You're going to have sodium tartrate forming. Don't know if that's soluble. Probably is. I'll say AQ. You'll get one of those, sorry. And then you'll get water as the byproduct, because acid and base always gives you water. The important part is here. 22.62 milliliters of 0.2 thousand molar sodium hydroxide and 40 milliliters of tartaric acid. Okay? Let's find out how many moles of sodium hydroxide that gives us. So N is equal to MV. Number of molarity is 0.2 molar times 22.62 thousandths of a liter, which gives us 4.524 times 10 to the minus 3 moles of NaOH. And of course, it's a 1 to 2 stoichiometry, so you're going to get 1 mole of tartaric acid, H2C4, H4O6 is titrated for every 2 moles of NaOH used. So which means you're going to get half as many moles of tartaric acid, so divide that by 2. And we get that you had to have 2.262 times 10 to the negative 3 moles of tartaric acid, H2C4, H4O6. And that amount of moles was present in that many milliliters of solution. I'm guessing they're asking for the concentration of the tartaric acid. Yeah, so the molarity of the tartaric acid solution, M, is equal to N over V. Therefore, that many moles, 0.262, or sorry, 2.262 times 10 to the minus 3 moles divided by the volume of the solution in liters, which is 0.040, or you could say 41 thousandths of a liter, you'll get the same thing, and divide that by 0.04. And what you get is a concentration of 5.655 times 10 to the minus 2 molar tartaric acid. You're only allowed 4 sig figs. Oh, you have 4 sig figs, so that's good. And you just write H2C4, H4O6. There's your answer. And then the last part is to write the net ionic equation. Well, the net ionic equation for any acid-base reaction is that proton reacts with hydroxide to give you water. So this is the net ionic equation for this reaction. H plus aqueous plus OH minus aqueous gives you water. I'm thinking this is going to stay in solution. So that's a spectator. The tartaric acid is a low enough concentration, that it's going to stay in solution. You're not going to get a precipitate of tartrate, sodium tartrate. I don't think so. It's too low of concentration for it to precipitate. Okay, guys. Trying to think what, yeah, I have to give you some kind of test. I'm going to give you 3 questions, okay? And you're going to take those 3 questions, write the answers nicely, and what can you do with them? If you email them to me. I would like to try that. You could try emailing me the answers to the 3 questions. You know my teacher email. I'm not going to say it online. Figure it out. At our school, first name dot last name at you know what. I'll give you 3 questions. You do them, email them to me, and I'll mark them, and I'll be able to produce a mark for you by the 23rd. Okay, so here we go. Let's do 466 480 and 476. Yeah, okay, sorry. 466, 476, 480. That's your mini test. Okay, guys? So do that. 3 questions. 466, 476, 480. Due in my email tomorrow at 6 p.m. by April 17th, 2020. That's for grade 11. Okay, grade 11, U, and grade 12C. All right, good luck, guys. We'll see you tomorrow. Bye.